Okay, this is 8.7 probability. This is first of probably 4 videos on probability. In this one, you will identify an experiment, a sample space, and an event. Find the probability of an event, find the odds of an event, and find the complement of the probability of an event. There we go. A happening whose result is uncertain is an experiment. The possible results of the experiment are called outcomes. The sample space is all of the possible outcomes, and each element of the sample space is an element. Okay, let's get the vocabulary out of the way. A happening is just something that happens. So a happening whose result is uncertain, something that you don't know, is called an experiment. And all the possible results are the outcomes. And if you list all the possible outcomes, that will be your sample space. And each piece of your sample space individually are events. So let me give you an example. Let's say a lady's having a baby. This is a happening. This is an event. Or not, this is not an event, but this is a happening. This is something that's going to happen. Because we don't know whether it's going to be a boy or a girl, we consider this an experiment. It's not an experiment as you would do in a science class, but for the sake of probability, this is the experiment because we don't know the outcome. All right. The possible outcomes is that she's going to have a boy or a girl. Those are the outcomes. And if you list out all the outcomes, a boy or a girl, then this is your sample space. Together, it's a sample space. She's either going to have a boy or a girl, excluding the fact that she's going to have twin, triplets, or other unusual situations. Normally, we would have either a boy or a girl. And each one of these choices or happenings, it's an event. So it's either going to be a boy event or a girl event. And each one of these events added together is the sample space. And because of this thing that's going to happen where you're not sure what's going to come out, is called an experiment. So I hope you got those terms straight in your head. All right. So sample space. List the sample space for each of these. A, tossing a quarter. What are all the possible things that can happen when you toss a quarter? You can either have heads or tails. Tossing a quarter and a nickel. You can have heads, 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 tails, tails, heads, and tails, tails. Tossing a quarter, a nickel, and a dime. You have heads, 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 tails, heads, 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 tails, tails, heads, heads, tails, 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 heads, heads, tails, tails, heads, tail, heads, tails, and tails, tails, tails. And there are 1, 2, 3, 4, 5, 6, 7, 8 of them. And you're looking at this, you might think that I duplicated some, but each one of these are unique if you look carefully. Okay? So this is a sample space. Each one of these individually is an element or event. I say element, I meant event. Okay, probability of an event. Okay, the number of events divided by the number of elements in your sample space is the probability of that happening. So basically it's what you want divided by what you don't want. If you're tossing a number cube or a dice and you want a 5, then there'll be 1 5 on all 6 sides of the dice, and there's 6 sides, so the total number of possibilities is 6, and the one that you want, there's only one number that you want, so it's 1 out of 6. Okay. Basic probability. Okay, let's start with just basic probability. We won't talk about the mutually exclusive, dependent, and independent events yet today. 2 coins are tossed. What is the probability that both are heads up? First, we're going to think about our sample space. We can have heads, 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 tails, tails, heads, and tails, tails. This is my sample space, and there are 4. And the one that I want is heads and heads, so it's 1 out of 4. What I want over all of the possible outcomes out of all the sample space. The coin and a dice are tossed. What is the probability that the coin will land heads up and the dice shows a 6 up? So here's one possible outcome. There's another one. Heads with a 1, heads with a tails. Heads with a... Sorry, I said heads with the tails. Heads with a 1, heads with a 2, heads with a 3, heads with a 4, heads with a 5, and heads with a 6. You can have tails with a 1, tails with a 2, tails with a 3, and tails with a 4, tails with 5, and tails with a 6. So there are 12 outcomes, and there's only one that I want, the tails with the 6. Now remember from the fundamental principle of counting, we have 2 ways that we can do a coin, and 6 ways we can roll a dice. So 2 times 6 is 12. Okay, fundamental theorem of counting. Odds. Now odds is almost the same as the probability, except odds is what you want by the what you don't want. So looking at the same problem that we just did with the probability, but now we're going to talk about odds. What are the odds of the coin landing tails up and the dice showing a 6? So same thing here. It's 1 out of my 12, but it's 1 that I want and 11 that I don't want. So that's odds versus probability. Probability of complements. A complement, the probability of an event plus its complement must equal 1. So you have this going on. The probability of of your event plus the probability of it not happening has to equal 1. Okay, the complement is it not happening. Or we usually write it this way: the complement is equal to 1 minus my probability. Or let's say we are talking about rain and sunshine. If it's 4 out of 5 chance it's going to be sunny tomorrow, that means the chance it's going to rain is 1 out of 5. So 1 minus 4/5 is 1/5. Okay, they have to add up to 1. Probability. Find the probability that a total of 7 is rolled on 2 dice. Okay, what's the probability that you can roll a total of 7 on 2 dice? Well, you can have, let's see, 1 and a 6, 2 and a 5, 3 and a 4, and so on. The easiest way to do this is to draw your entire sample space. This is your entire sample space. You can either roll a 1, 2, 3, 4, 5, or 6 on one die, and then a 1, 2, 3, 4, 5, or 6 on the other die. And together, you're going to have this sample space in here. And how many ways are there to make 7? It'll be 1, 2, 3, 4, 5, 6. 6 out of 6 times 6 is 36. So that reduces to 1/6. So probability of a 7 is 6 out of 36, or 1/6. Find the probability that a total is less than 6 on 2 dice. Okay, it helps if you have your sample space. Less than 6, how many of these are less than 6? Those are less than 6. So you have 1, 2, 3, 4, plus 3, plus 2, plus 1. So that makes 10 out of 36, my total sample space. So the probability of less than 6 is 10 out of 36, or 5/18 reduced. Find the probability of winning the lottery for choosing 6 numbers correctly out of 49. Okay, so since it's a probability and the order does not matter which way you pick these numbers, we can use this combination notation. You have 49 numbers and you're going to choose 6 of them in a combination. That means it's going to be 49 times 48 times 47 times 46 times 45 times 44, because there's 49 numbers to choose from. Once you choose one, there's only 48 numbers: 47, 46, 45, 44. And from yesterday's video, you know that the fundamental theorem of counting, you multiply all of these together. Okay, and then you have to divide it by 6 factorial, which is 6 times 5 times 4 times 3 times 2 times 1, because this is the number of ways that you can rearrange these 6 numbers, and because order does not matter, then you're going to get 13,983,816, or almost 14 million, is your sample space. Well, how many ways out of these are there to win? There's just one. So you have to pick exactly those 6 numbers out of 49. So your probability that you're going to win is 1 out of almost 14 million. Okay, what is the probability that the sum of 2 dice is not 7? All right, not 7, those are not 7. Okay, or actually you can say the probability of not 7 is equal to 1 minus probability of 7, and we know the probability of 7 is 1/6. So 1 minus 1/6 is 5/6. What is the probability that the sum of 2 dice will be less than 8? Okay, pause this and figure this out and see if you can get this right. Alright, hope you have an answer. Less than 8 would be all of these, and that would be all of these added together, or 21 if you counted them. 21 out of 36 would reduces to 7/12. Or you can add like 1, 2, 3, 4, 5, 6. That's how I put this one here. Because probability of getting a 2 is 1 out of 36. Probability of getting a 3 is 2 out of 36. Probability of getting a 4 is 3 out of 36. Probability of getting a 5 is 4 out of 36, and so on. What is the probability that the sum of 2 dice will be greater than 9? Okay, pause this one and see if you can get this while I have some chocolate cake. Okay, all right. Greater than 9 is 10, 11, and 12. 3 ways to make 10, 2 ways to make 11, and only 1 way to make 12. And that will be probability of greater than 9 is 6 out of 36, or 1/6. What's the probability of the sum of 2 dice will be odd and divisible by 3? This is easiest to do with a sample space. All right. The probability of them being odd and divisible by 3. 5 is odd, but it's not divisible by 3. So you have to eliminate the 5s. You have to eliminate the 7s and the 11s, okay? Because even though they're odd, they're not divisible by 3, and these are the only ones. And you have to eliminate the 6s. They're divisible by 3, but they're not odd. So how you can actually come up with that is you take the probability of getting odds, which is a half. Half of these numbers are odd, 18 out of 36. And the numbers divisible by 3 are 12. There's 12 divisible by 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 divisible by 3. And because it's an and, in order to eliminate these, you multiply your individual probabilities. So 1/2 times, because it's and, 1/3 is going to give you 1/6, or 1, 2, 3, 4, 5, 6 out of 36 reduces to 1/6. This is how you can do this without writing out the sample space. If you knew that the odds is half of them are odds and divisible by 3, 1/3 of the numbers are divisible by 3, multiply them together, you're going to get the odds and divisible by 3. All right, please do the Google form.